started. Now, what we're looking at today, and possibly Monday, is exploring more about parabolas. Now, a parabola, we can write the equation, set it up based off of a point called the focus and a line called the directrix, and all the distances between them. Because it works out that the distance from the focus to a point on the parabola and the distance from that point on the parabola to the directrix will be the exact same no matter where it is on the parabola. Now, we're not going to focus too much on actually how we can go about finding the equation from that information, but we do have two general equations for these parabolas. The first one is y equals 1 over 4p times x squared, where the focus is 0, comma p. The directrix is going to be y equals negative p, and the axis of symmetry is x is equal to 0. Now, the other equation that we have is x is equal to 1 over 4p times y squared, where the focus is p comma 0. The directrix is x is equal to negative p, and the axis of symmetry is y is equal to 0. And really all of these here, these equations that we get, are coming from the fact that the vertex is going to be the point 0, 0. The vertex for all of these here that we're going to look at today is 0, 0. Now, there are other equations that deal with this here, because really the focus is h and k. Because if the vertex was not 0, 0, we would have to change and alter these a little bit. And when we get to that, we'll see the other equations. But for today, we're mainly focusing on setups when the vertex is at 0, 0, where it crosses the y-axis, intersects the x and y-axis. Now, let's look at our first equation here. We have negative 4x equals y squared, and we want to identify the focus, directrix, and axis of symmetry. Now, we have one of two general equations. We have the x is equal to 1 over 4p times y squared, and our y is equal to 1 over 4p times x squared. I don't think so. You're welcome. Which one of these two equations, general equations, most closely matches up with what we have to start with? This one here, yes? Move it down just a little bit. And it's really because we have x to the first in both of those, yes? And the y is squared in both of those. So that would be the general equation that we're looking at. It would not be this one here. So what this tells us is some important information, because since we know that we're looking at the x equals 1 over 4py squared, well, it tells us that the focus is going to be the point p comma 0. Our directrix, R-E-C-T-R-I-X, is x equals negative p. And the axis of symmetry is y is equal to 0. Now in all three of these here, what is the only thing we're missing? Because we have the focus at P0, yes? The directrix is x is equal to negative p, and axis of symmetry y is equal to 0. Well, we know what the axis of symmetry is. Y equals 0, yes? We have that. Well, x equals, what is p? Do we know what that is yet? No. So that's really what we're going to be finding, because once I can find the value of p, we can plug it in and we will have the focus, directrix, and axis of symmetry. We'll have everything. We just need to find the value of p. And to do that, we're going to be manipulating this equation here, the negative 4x equals y squared. Well, one of the first things we're going to need to do is actually get this so it's in a similar form to our general equation. The x is equal to 1 over 4p times y squared. In this here, the x is by itself, yes? And the equation they gave us is x by itself. So what do I need to do to get the x by itself? We can divide by negative 4. And if we divide both sides by negative 4, well, negative 4x divided by negative 4 will just be x. Over here, we're going to have y squared divided by negative 4. Now, because of our properties of fractions and multiplication, we can actually move the y out to the side, because 1/4 or negative 1/4 times y is the same as y over negative 4. Those are the exact same. Any questions on this here? Is the x by itself? Yeah. Does this look like the general setup for the general equation? Yeah, we have x equals, well, really a number, 1 over 4p is just a number, times y squared, yes? Because here we have x equals, well, we have a number, times y squared. And when we look at this here, the x's do match up, the y squareds do match up, and the negative 1/4 is really matching up with what? The 1 over 4p, because those are in the exact same place, yes? So whenever we plug p into 1 over 4, it will eventually give us negative 1/4, yes? So if I want to find the value of p, because we do have it set up in the same way, it's really that 1 over 4p is equal to our negative 1/4, because those are in the exact same place. And if I want to find the value of p, we can set them equal to each other. Any questions on this here? Okay, now we need to solve for the value of p. What can we do first? We're going to multiply both sides by 4p. Because I'll go on and write this out. 4p times 1 over 4p. Well, this 4p multiplies with the 1, which would give us 4p over 4p. Here, this 4p will multiply with the negative 1, so negative 4p divided by 4. What is 4p divided by 4p? 1. Negative 4p divided by 4? Negative p. Any questions on this so far? Oh, we need to solve for p because we're not quite done. We need to divide by negative 1, which tells us p is equal to So we found the value of p. Yeah, it's -1. So now all we have left to do is to plug it back in. We good? Okay. So we come back here to the focus, directrix, and axis of symmetry. Well, the focus, if I plug -1 back in, it will tell me that the focus for this is -1, comma 0. The directrix, x is equal to -p. Well, that would give me what? It was +1 because the -1 would become positive. A negative and a negative would make a positive. So we have 1. And that's it. So the focus is -1, 0. The directrix is x is equal to 1. And the axis of symmetry is y is equal to 0. And that's it. That is our answer. Questions on this here? We ready for the next one? Identify the focus, directrix, and axis of symmetry of -2x equals y squared. And we're not going to focus on graphing the equation. So looking at this here, which is our general form for the equation? So is it going to be our x equals 1/4p times y squared, or y equals 1/4p times x squared? X equals, so what gave us that idea or notion that it's going to be x is equal to 1/4p? Because we have y squared. Y squared is the term that's squared, so that's the one that we're going to use. Now for the focus, directrix, and axis of symmetry, what are we really missing from all three of those? The value of p in all of them, yes? Because if I had the value of p, I can actually finish out the focus, directrix, and axis of symmetry. So to really find the value of p, well, we need to take our -2x equals y squared and rewrite it or manipulate it so that we do have the x by itself. And to get that, we would divide both sides by -2. Because -2x divided by -2 would be x is equal to negative y squared over 2. Or really, we can just say x is equal to -1/2 times y squared. Okay, so what do we need to do next to solve for the value of p? Because what we're looking for is the focus, directrix, and axis of symmetry. And to do that, we need the value of p. Well, p shows up in the 1/4p, yes? And in our setup, x equals, we have that, yes? We do have the y equals. And then we have a number being multiplied in front of it, yes? In the general equation, that number is 1/4p. Here we have -1/2. So if I want to find out what the value of p is, well, I can set 1/4p equal to -1/2. And then what can we do next? We're going to multiply both sides by what? 4p. And we do this because since the variable is in the denominator, we need to get it out of the denominator by multiplying both sides by it. So here, 4p multiplied by 1/4p is 1. On the other side, we're going to have what? -4p over 2. What is negative 4p divided by 2? Negative 2p. And last but not least, divide by negative 2, because we do need to officially get p by itself. And this will tell us that p is equal to negative 1/2. Now our focus is normally p comma 0, yes? Well, what's the value of p? So we have negative 1/2 comma the directrix is normally x is equal to negative p. Well, negative 1/2 would be 1/2. And the axis of symmetry is y is equal to 0. Because the p value is only going to go in the focus and directrix. Those are the only two places that the p value will go. Any other questions on this here? We're ready to look at the next one. All right, so we again want to identify the focus, directrix, and axis of symmetry. And they gave us the equation y equals 0.5x squared. Which general equation would we use? It's just a number, isn't it? So y equals 0.5x squared. So on the last ones, we had to get the variable that didn't have the exponent by itself, yes? Do we need to do anything for this one here? No. Well, here, the general equation y equals 1 over 4px squared, yes? The number without the exponent is what we want by itself. So for the equation they gave us is the variable without the exponent by itself. Well, yeah, so we don't have to do anything to it. So the 1 over 4p is matching up with what? 0.5. So if I want to find the value of p, we can say 1 over 4p is equal to what? Is going to be equal to 0.5, because that's where p is located. Even though it's not a fraction, that's fine. We know that whenever we plug the value p in to 1 over 4p, we should get 0.5. So what do you think we should do first? What should we do first to find the value of p? And we do this because 4p times 1 over 4p is? Now we need to do 0.5 times 4p. And then so p is equal to what? 1/2. P is equal to 1/2. Questions on this here? So let's look at the focus. Focus is normally what? Zero comma because since we're not looking at x equals anymore, we're looking at y equals, the focus is 0p. 0, and our value of p is? So the focus is 0, comma 1/2. The directrix is y is equal to, normally it'd be negative p. So here it would be negative 1/2. And lastly, the axis of symmetry is x is equal to 0. And that's it. Y equals negative p. Any questions on any of this here? Let's look at number 3. Negative y equals x squared. Well, which general equation does this match up with? 1 over 4p x squared. And we can really tell because y is to the first power, we do have x squared. This is going to be the general equation. Now, is the equation they gave us already in this form? What do we have? Negative y equals, is that the same as y equals? No, because the value of y is what? Negative. We need it to be positive. So the y value is negative. We need it to be positive. Yes? Let's focus back in. So what can we do to this equation, to both sides, to get the y value to be positive? So we can divide both sides or multiply both sides by a negative 1. Because negative y divided by negative 1 will be just positive y. Negative or x squared divided by negative 1 would be negative x squared. So the main thing we wanted is that the value in front of y is positive. So now our equation is in a similar form to the general equation, yes? No? Okay. What matches up with our 1 over 4p? Because what's being multiplied by x squared? Negative 1, yes? So what is taking the place of 1 over 4p? Negative 1. So we can still find it. So 1 over 4p is going to equal what? Negative 1. Even if that sign wasn't there, we could still do it. Because if it just said y equals x squared, the number that 1 over 4p would match up would be 1. Now what do we do next? Multiply both sides by 4p. And again, 4p times 1 over 4p is 1. Negative 1 times 4p is negative 4p. Now what can we do next? Let's focus up here. Caleb. Thank you. So p is going to equal negative 1 over 4. Any questions on this here? But we still need to find the focus, directrix, and axis of symmetry. Now our focus, because we do have y equals is 0, comma, p. So we'd have 0, comma, negative 1/4. Just a little bit. The directrix is going to be y is equal to, so it's negative p, yes? So we would have what? Negative 1/4. Well, a negative and negative make a 1/4. And the axis of symmetry is x is equal to 0. Any questions on this here? Any questions on anything we've done so far? All right, so this last one here is going to match up with our x is equal to 1/4p y squared. Well, I know it's that one because we have a y squared. Now, do we need to manipulate our original equation a little bit? Well, yes, because the x is not by itself. Now, we can divide both sides by 6, or what we can do is we can multiply both sides by 1/6. Because if I multiply 6x by 1/6, what does that give me? Well, I have 6x divided by 6, which would just be x. On the other side, I'll have 1/6 y squared. Was multiplying by 1/6 the same as dividing by 6? Yeah. And sometimes when we're dealing with fractions, it's sometimes a little bit easier to multiply by their reciprocal if we flip the fraction than it is to just divide by the fraction itself. Well, what are we setting equal to 1/4p? Because the 1/4p matches up with the 1/6. Y squared and y squared match up x and x. So the only thing that's really dealing with 4p or p is the 1/6. What do we do next? Multiply both sides by 4p. Now the 4p and 4p will simplify, leaving us with just 1 is equal to 4p over 6. Now what can we do next? Because we can multiply by 6 and divide by 4. And this here works out very interestingly, because 6/4 times 1 is, well, 6/4. Yes? So if we multiply these together, well, the 6 and 6, 6 divided by 6 is 1. 4 divided by 4 is, so I'm just left with p. So most of the time, if we just have a number, we can divide. If we have a fraction, dividing by that fraction is the same as multiplying by its reciprocal, by just flipping it. What is 6 divided by 4 reduced to? So what is our focus for this setup? P, comma, 0, yes? Our value of P is S, comma, 0. Our directrix is x is equal to negative P, so it'd be negative 3/2, and the axis of symmetry is y is equal to, and that's it. Questions on any of this here? Questions on anything we've done so far today? Okay. These here are the actual equations. These are the actual equations that we work with, given this here. So they're not in the note sheets. They will be eventually. And axis of symmetry is, we'll look at this one first, and if we have time, we'll look at the other one. But this here is the general equation that we have. Now, one of the things I said at the start is that the vertex that we're dealing with for all the ones today was at the point 0, 0, is at the origin, yes? Well, if we look at this here, so the focus is h plus p comma k, yes? So if the focus, or the vertex is at 0, 0, we have 0 plus p comma 0, yes? What is 0 plus p? Well, it would just be p comma 0, wouldn't it? Is that the same as our focus for when we have x equals? Yeah, so the directrix is x is equal to h minus p. Well, for us, that would be 0 minus p, which is just negative p. Is that what it told us? And the axis of symmetry is x is equal, or y is equal to k. Well, that's just y is equal to 0. Isn't that what we have over there? So when we do get, an actual point off the vertex, when the vertex is off the intercept, the 0, 0, we'll be using this. But really, once we find h and k and p, for the focus, directrix, and axis of symmetry, we're just plugging in h, k, and p and finding our values. Now, the other interesting thing, or at least I find it interesting, is that this equation here is the exact same as x is equal to 1 over 4p y squared. As we said again, h and k are 0, because that's the vertex. So here it would just be 1 over 4p, x equals, times y minus 0 squared plus 0. Well, what is y minus 0? Why? Because if we add 0 or subtract 0, it doesn't change anything, does it? So really, this is gone, and we're just left with what? Y plus 0, that's gone. Wait a minute, that's the same equation we have here, isn't it? X equals 1 over 4p y squared. They are the exact same equation. It's just because the vertex is 0, 0, we don't include the h and k. Now we're gonna